All right, so now we're getting ready to start looking at linear inequalities. We have one section of the book devoted to this, and they're really not too bad, these linear inequalities, but we're going to break it down into two parts. We're going to break it down into graphing, which is what's on this first board, and then in a few minutes here, we'll look at solving them. And yeah, so we'll just take it as two parts. So graphing linear inequalities. We have to figure out two things to make a graph for a linear inequality. What kind of circle to use and what direction the arrow points. That's really it. So for the circle, it's pretty straightforward. You use an open circle if you have a less than or a greater than sign, because what that means is that the number we're looking at doesn't actually count. And we'll look at that here in just a second. Or we can use a closed circle if we have a less than or equal to or greater than or equal to sign, because now the number actually gets included. All right, so that's the kinds of circles, and again, I have some examples here. We'll get to those in just a second. And then the arrow. We need to figure out which direction the arrow is going to point. Okay, does it go left or does it go right? Now, to do that, we can pick any number that works that makes the statement true and just send the arrow in that direction. So here are two examples. First, I have x is less than or equal to 3. So when I make these number lines and graph these linear inequalities, I don't need a whole pile of numbers on my number line. It is enough for me to show 0 as a point of reference, and then since I'm looking at 3, I'll put 3 on the number line, and of course 3 is over to the right of 0 on a number line, so that's where I put it. That's all I need. Okay? I don't need 1 and 2 and -1 and negative. I don't need all of those. I just need 0 and 3. So this time I notice that I have the little line under the symbol, which means that 3 is part of what works, right? 3 is less than or equal to 3. Kind of a weird statement, but that's how it works. So this one is going to have a closed circle because the 3 counts. So you'll notice I have a closed circle at the 3. The only thing left, figure out which way to send the arrow. So the easiest way to do this, again, is to pick a number that works. Well, I need stuff smaller than 3. Something that, so what's smaller than 3? 2, 1, -18. All of those are going to be to the left-hand side of 3. And so you'll notice I made my arrow come over to the left of 3. And that's it. That's my graph. My second one, I have -2 is less than x. And so now this time, -2 doesn't count. There's no little symbol underneath that would allow that to be part of the solution. And so I use the open circle. So I have an open circle at -2. There's my 0, just to give a point of reference again. And now I'm trying to decide, okay, what is actually going to work here? What's bigger than -2? Well, I don't know, -1, 0, 5. And so I have my arrow going to the right. And so that's really a pretty good trick. Pick a number that you know is, in this case, bigger than -2, or that you know is smaller than 3, okay, or whatever that relationship in number might be for you. Pick a number that you know works, and then send the arrow in that direction. So now that we're going to get into solving, these really aren't too bad. If you got through the equations earlier in the chapter, you're going to be just fine here. And so let me clear the board off, and we'll look at those. All right, so now we want to move into solving. So you'll notice I have a couple of steps here we're going to look at. I'm actually going to save any examples for the next board, and you'll see why, because I just needed a little bit more space here for something. So to solve, it's going to be exactly the same as when you solve for equations. Okay? Nothing different about it, except there's one exception. If you multiply or divide by a negative number, not add or subtract a negative, we don't care about that. If you multiply or divide by a negative number, the sign in the middle switches directions. And let's look at an example maybe to try and clarify why that happens. So here you can see I have the statement that 1 is less than 10. I don't think I'm going to get any argument out of anybody on that one, right? If you have $1, that's not as awesome as if you have $10. Well, let's multiply both sides by -2. right? Because the claim is that the sign has to switch if we multiply or divide by a negative number. Well, 1 times -2 is -2, and 10 times -2 is -20. Now it's backwards. -2 is bigger than -20. And if you don't believe me on that, just think about it in terms of money for just a second. Would you rather owe $2, not a great thing, or owe $20? That's worse, right? You'd rather owe 2 than 20. So -2 is bigger than -20. So the only way we can go from the beginning statement to the bottom statement and keep it actually working is to turn that symbol in the middle around. So that's really the only thing you have to watch out for here. We'll do like 1 or 2 examples of solving these, but that's really the only thing to watch out for. Okay, so I have 2 examples, and then we'll be all set and finished up with chapter 2, and that will be fantastic. All right, my first example, 8 is greater than or equal to 3x minus 4. So it's just like an equation, I just have a funnier symbol in the middle, so I'm going to do all the same steps. I start by adding 4 to both sides, that gets rid of the 4 on the right, 8 plus 4 gives me 12. I divide both sides by 3. Now please notice this is a positive 3 I'm dividing by, so I didn't turn my symbol around. 12 divided by 3 gives me the 4, and I just get that 4 is greater than or equal to x. You'll see I made a graph out of the solution, so I put 0 and 4 on my number line. I used a solid dot because of the line underneath, which includes the 4. And this time I need 4 to be bigger than whatever x is, so 4 needs to be bigger than something. So I pick a number, I don't know, 2. 4 is certainly bigger than 2. 2's over here on the left, so my arrow goes to the left. My second example, this one's going to have a negative on the x. We're going to have to divide by it, so that's going to be the thing that we see here. We have -2x plus 5 is less than -7. So just like with any other equation, I start by subtracting. I subtract the 5. -7 minus 5 is -12. So now we have -2x is less than -12. Here's that key step. We're dividing both sides by -2. Leaves me with x. And then we have -12 divided by -2 and gives me +6. But because we divided both sides by a negative number, my sign has to switch directions. So instead of having less than the number, now I have x is greater than 6. So again, I make my graph. There's 0 as a point of reference. 6 goes over here. It's got an open circle. Very fun because it's not including the 6. And this time I need x to be the bigger thing. So what works? I don't know. 7 is bigger than 6, and that's over here somewhere. So there you go. That's solving linear inequalities. They're not too bad. They're really pretty straightforward. And I know you can do this. Good luck.